Hello friends, welcome to video or question number 21 overall of the DSA practice group and question number 3 of Qs. Okay, before we jump on to this question, especially for the people who are watching the video for the first time, who are on the channel for the first time, let me tell you about the link which is flashing below, which is for a group where you can join for practice of data structures and algorithms. These are those only questions which are going to help you master data structures and algorithms and will help you earn from 12 to 30 lakhs of INR as an annual package if you are in India, even if you are a fresher, even if you don't have a degree, right? Even if you have no kind of experience, and even if you think you are stupid, okay? Because you are not, right? So whatever it is, these are the videos, these are the question practice which will help you do that. And companies like Amazon, Microsoft are really interested in people who are smart, who are problem solvers, and this is a skill which can be mastered if you do the practice, if you do the practice of the right principles, that with the right guidance, following the instructions properly. So in this practice group, a question is posted regularly like this, the one which you are seeing right now, and my students try these questions by themselves. They think for themselves, they try and think of different ways, they try to optimize the code, they try to compare it with other solutions, right? They time themselves how long it took them and they try to do it. If they get stuck somewhere, they post a comment or post a message and I get back to them and give them tips. I ask them certain questions and guide them in the right direction so that they should be able to solve the question by themselves, right? And guess what? Even if you are not able to solve, even after the tapes, even after taking so much time, over a very small period of time, generally 24 hours, the solution of the question is posted in the form of a video like this, or maybe in the form of some tapes or just a written post. Okay, so sooner or later you are going to be able to do the question, right? So let's say if you are a fresher, if you are a fresher who doesn't even know the basics, right? Maybe you don't know the basics of the programming language, right? You don't know how coding works, or you don't understand what data structures are, right? But if you watch the video and copy me along, maybe multiple times, right? I'm talking about someone who doesn't know anything, right? Just copy me along, listen to my audios, listen to my videos multiple times, copy the code as I'm doing so. Sooner or later it will go inside your head, right? The only problem that we have is we don't put focus, right? Anything that we learn in life comes through that, right? So with the help of these videos, your journey is going to be very short and very fast for mastering this. And if you're working outside India, you can easily get a package of 100k or 200k US dollars if you master this concept, right? The only question is, are you willing to put in that effort? Are you willing to go ahead and follow the instructions as I'm saying? Are you really up for giving your best to it, right? So click on the link, join in, right? Join in and become part of my community, right? I myself, Akshay from IT Delhi, BTech Computer Science graduate, having worked in companies like Amazon and the like as software engineer, senior software engineer, and also have trained multiple students in working in other MNCs like Microsoft, right? So you can also join the lot, right? And you can master that practice, that formula, that secret formula which can help you master these techniques in maybe just 1 month and crack those interviews in just 3 months. Okay, so click on the link and join. Maybe subscribe the channel also right now so that you get regular updates. Now let's jump on to this question. Okay, this question number 21 is design circular queue. Design your implementation of circular double-ended queue or DQ. Okay, so if you are someone who doesn't know what a queue is, what a circular queue is, you can probably watch the previous video, because in that video I shared another question talking about circular queues and I explained a lot about queues. I gave even more insights about interview cracking things, right? So in this video I'm going to talk about circular DQs. So you should probably watch that video first and then join here. Okay, but in short, let me just explain to you what a queue is, what a DQ is, and what is a circular DQ, right? So a queue, as we know, is a kind of a data structure, is a kind of storing information in a way that whatever comes at whatever order that information is coming in, the same way the information will go out, right? For example, let's say let's talk about this kind of a machine which exists. So if you're going to put any kind of information, let's say this information, I'm going to put this, right? So this is the head and this is the end. So when you push through this, what will happen? The head of the thing is going to come out first, right? So that's what a queue is. Whatever goes in first comes out first, right? Now you understand the queue probably much better, right? And what is a circular queue? This might be a bit advanced thing. So data structures have the purpose of storing information in a way that it becomes easy to process on them, right? When you talk about easy processing, it is in terms of the how a coder uses it, how the end user uses it, how much time is taken by the computer in executing the code, and how much resources in the form of maybe battery or memory the computer uses for solving it, right? So you have limited resources. Sometimes a circular queue is used for storing information, because when you store information in circles, let's say you have only 5 elements, right? Let's say these were the 5 elements, 1 2 3 4 5. This was a queue. So first element came over here, second over here, third over here, fourth over here, fifth over here. Great, right? So when you want the first information, the information will go out from over here and this becomes empty, right? Now you want second information, so information will go over from here and these two spaces will become empty while information is still present here, here and here, right? Now let's say another information comes in. Okay, it is supposed to come to sixth position, but I don't have a sixth finger, right? Similarly, your data structure may not have more resources, right? It may be having space only for 5 elements. But if you are using a queue which has 5 spaces like this, these two spaces are going to get wasted, this one and this one, right? So a better solution would be that whenever new information comes in and if you have any extra space left over here, you take this three information and move it, take these three information like this, right? And move this over here, as a result of which this information is stored over here and over here, while these two places become empty, so that the new information which comes in can be stored here and another information which comes in gets stored over here, right? But this is an expensive operation, right? Why is this an expensive operation? Because let's say the memory element that you are using had n elements, n sub elements or sub n elements in the queue, right? So if you have to copy this entire n elements, maybe by even one position, you are going to take a time of n operations, right? So a better way to solve this problem is to maintain circularity, right? So let me explain to you like this, okay? Let's say the information is stored in circle like this, 1 2 3 4 5 and again back to this, right? So let's say information came, first information is stored here, second information is stored here, third information is stored here, fourth is stored here and fifth is stored here, right? Now let's say this information is read, so this one goes away. As a result, this became empty, right? So let's say a new information comes in, right? We will need a sixth finger, but instead of creating a next sixth finger, you can directly store that information, the new information to this. Why? Because this is empty, right? And our beginning of the queue will begin from here, right? So this is the new beginning because that is where our current first information is stored, and in this order the information is stored in 5 places, right? That's why a circular queue becomes important, right? So let's say another information is read and this one goes away, so this will become your new first, right? And we will go from here to here, and if any other new information comes in, you will store it over here, right? So that's the importance of a circular queue. Now we are coming to a circular DQ, right? There's a very slight difference between a queue and a DQ, which is both have the same functions, but in a queue we have only the current element, let's say this element has access, we can only go in one direction, right? Given a queue, you can move in only one direction, right? For example, uh, yeah, so let's say these are the 4 elements inside the queue, right? So our queue works in this way that you can go remove the elements from this direction, you can enter the element at this place, right? sorry, you can enter the new information only from the rear end. So information goes in this direction, right? And order is maintained. You remove from here and you add over here. But in a DQ, there are certain more ways, that is, you can add information even here also, and you can remove information from here also, right? Order is maintained, right? It is just like saying, like if a person can count from let's say 1 to 5, 1 2 3 4, the person is allowed to do the counting from 5 4 3 2 1 also, right? It's very simple. So that's the basic difference between Q and a DQ, and we can see that by seeing the operations also which we are being asked to perform, right? So let's see what those operations are. One is my circular DQ, then insert front, insert last, delete front, delete last, right? Get front, get rear, is empty, is full. Okay, so I'm going to again emphasize on a point that always spend a good amount of time on understanding the problem, right? If you understand the problem, your 50% of the job is done. The problem always has a solution inside it, and this is not something esoteric. This basically is practically true also. The question always have the solution, and you know why? The question basically gives you the constraints, right? If let's say you're going in a maze, right, you don't know which direction to go to, but if you know the rules of the maze, you will get a direction, right? Similarly, if there are certain constraints, it basically tells what all you cannot do, and once you eliminate what all you cannot do, the right path emerges, right? So that's why always spend a good amount of time in understanding the problem, right? Maybe 50% of the time would be used in understanding the problem, thinking of the answer, mathematically proving it, and a very short amount of time, maybe 10% in writing down the actual code of it. Okay, 50% is probably understanding, then remaining time in thinking, practically proving, and maybe just 10% time in the actual coding work, right? So I'm going to take some time in explaining to you this problem. You also do that in whatever problem you have. Okay, so first thing is my circular DQ, which is same as the name of the class, right? So this is basically a constructor, and it sets the size of the DQ, right? Remember, the circular DQ already has a fixed size, right? We created like this, it has a fixed size, right? So as a constructor, it gives us that input. The second function, or the first function it wants, is insert front, which basically says adds an item at the front of the DQ. Return true if operation is successful, right? So why is it returning true? The thing is, sometimes the queue can be empty, and when it is empty, the answer is going what? How do you tell the user that the queue is empty and you could not really perform? Sorry, the queue was not empty, the queue was already full, right? If the queue was already full, how do you tell the end user that we tried to call insert front, but because the queue was full, we could not, right? What you do in that case is you will return false. And if the queue was empty, had some space, and you were able to insert something, you will return true. Okay, great. It is actually the same for an outside user when you compare it to a normal circular queue. There's no big change in that. Next, insert last. Adds an item at the rear of the queue. Return true if the operation is successful. Right? Now you get to insert the element also at the last position. You are going to insert in the front as well at the end. This is something different from a usual queue. Okay, so that's the case. Great. Next thing that you have is, you have done with the two operations on the front, two operations on inserting. Now let's deal with two operations which are about deleting, right? So now you can delete from the front also, and you can delete from the rear of the queue, right? And this is what is exactly makes the queue like a DQ. Okay, this is what makes the queue like a DQ. Great. Then we have two operations, get front and get rear, which basically means you just need to access the information which is present at the beginning of the queue, at the end of the queue. You don't need to perform any operation, and you will see that these kinds of operations which are just access based, they are not really complicated, and they don't generally contribute to the time and space complexity. except for the cases when the interviewer or the real life problem that you're facing requires other operation like inserting to be extra fast, right? They want you to be extra fast, and they don't care that you take more time in inserting, right? For example, a log file. When you have a log file in consideration, the only thing that you care about is as soon as an operation is executed, the corresponding log is inserted into the file immediately. Though when you are trying to look out for that log, it will take time, right? So an extra operation is going to take time, but it won't matter. Why? Because in log files, the purpose of accessing would be done very rarely, but the operation of insertion will be done very regularly, right? So in that way, you will always have to analyze the question, the real life problem, and see which operation do I want fast and which operation it is okay to go slow, so that you can have a good code optimization on the basis of the problem. Great. Similarly, we have get rear, which is get the last element from the queue, and then is empty and is full. Okay, simple as that. Now, I won't go into much details about the how you actually do that, because it will become almost the same as what we did for the circular queue, but we are going to do a small comparison between the queue, the code, and the DQ code. Okay, but before that, let's jump on to my circular DQ's code and see what is there. Okay, so this is a very brief that I'm going to take you through this. For more elaborate one, you can probably watch video number 20, which is for designing of circular queues. Okay, so this is a constructor, insert front, right? Insert front, great. Then insert last is there, delete front. This is actually the same that we just did. So let me just copy paste the code which I have already prepared for this, right? And then we can understand how this code works, or how one can come up with, and we are going to analyze something very specific related to code optimization and comparison of different kind of data structures. Okay, so I'm not using an array in this. You can probably use an array also to do the question, right? Because the size is already fixed, so you can use an array. Okay, but I believe for teaching purpose, and also for someone who is beginning to practice the interview problems, it is important that you get to see a lot of different ways of solving, and especially the most basic way of solving. Because if you understand the basic, if you get the seed of a fruit, you can sow that seed anywhere and get the tree coming out from anywhere that you want, right? If you're just going to focus on the branches and the leaves, right, or maybe just the pulp part of the fruit, you will be able to feed yourself only once. But if you get that seed right, the basic thing right, you can sow that seed anywhere and get those results, right? So my approach is going to be very basic. You are free to try this with the help of an array. Okay, and how do I define this class? This is known by understanding the need of the question, right? So let's not go into the code of this, but let's see what the different functions which are being asked in the code and how do we implement it, right? So first one is the constructor my circular DQ, which passes an int as an input, right? And it just wants that to store that information, right? Maybe I may need to do a lot more operation on the k, but for now, when I'm beginning to write the code, let me just store this value max size, int max size equal to k. Okay, maybe later if we identify that we need to do more, we can modify the code. Okay, but for beginning, just focus that I have written just this code, and therefore for this max size will have to be saved somewhere. So I save int max size equal to -1 when the DQ has not been initialized. Great. Next one is add an item at the front of the DQ, right? So this is basically public boolean insert front int value, right? So basically you are supposed to insert the value, the new value which is coming in at the beginning of the queue, right? And when you are inserting at the beginning of the queue, this element is going to get removed first, right? So if I have kept the code of the circular queue also ready, right? In that you can see uh, this part of the code looks something like the one that we are doing right now. It is about public boolean NQ. Okay, this is about the public boolean NQ part of it, which basically means insert a new value, but this value is going to be inserted at the rear. At the rear, as you can see, tail.next is equal to new node, right? So this NQ is not the same. This NQ is not the same as our insert front. Okay, because this is inserting the value at the front. That's the difference between a normal queue and a DQ, that you can insert at both the ends in a DQ, right? So this code is going to be a bit different, right? So let's say we have not written any other part of the code and we are going to insert at the front, right? So let's assume we already have a queue ready with us and we want to insert at the front. What information do we need? We need the information that we need is the pointer or the index of the first element in the queue, so that we can just go one in front of that and insert it, right? So that's why you will, that's why if you're using an array, you will use the index. You will have to create an integer index, which is the head. And if you are using a node or a linked list kind of a thing, you would have to create a node like structure, which is called the head, right? So that's what I did. I realized in my node definition I would need, one thing is the value, right? And the second thing I will need is the next, so that link hopping can be done. Okay, link hopping can be done. But okay, so let me just show you the code also. So I created this class node, I inserted the int value in this, I inserted created the ability to create node next, but in addition I'm also doing a node previous, right? Why I'm using node previous you will get to know in a short while, but for now let's just go ahead with what we have. So insert first will first check whether the current existing list of nodes is empty or not. If it is empty, then there's no problem at all, right? You can just set the head equal to the new node and you will be done, right? And we will also be needing a tail pointer, right? Because we already know the question asks us to insert and delete at the beginning as well as insert and delete at the rear, right? So if we want order one complexity, it is better if we store these pointers, right? That's why in this code I have stored node head as well as node tail, right? So till now I have justified to you why I am using these three variables. Okay, max size, head and tail. But when you will be doing yourself, more than just a justification, you will need a formal mathematical proof at least in your head. When you're giving the interview or during the time you're practicing, maybe spend 1 to 2 hours on identifying why these things are enough, right? Why these things are enough, because until unless you're going to be clear in your own head, you are going for just trying out your luck, right? And interviews are not won on luck, they are win on the basis of the hard work, which is focused. Okay, focus on the right parameters, the right foundation, the right basic principles, right? Great. So max size is less than equal to 0, then return false. This basically means if in the question someone has goofed up or did something just for fun and set the max size as negative, then you cannot really insert in the circular DQ, right? Because the max size is negative. So in that case you will simply return false. Okay, and let's say now the max size has been seen, that is not something like a stupid value, right? Now what you have to do is you have to just create a head equal to new node with the value, and you will assign the tail also equal to head, right? And you will assign size equal to 1 and return true. Now these four operations are very beautiful, because very beautifully they ensure that the constant of the DQ is maintained. If you had broken the constraint of the DQ, the properties which make a DQ during this execution, maybe this function will work correctly, maybe some other functions may also work correctly some of the time, but there will be a case where it may fail. But because I could do this mathematical proof in my head about how we are doing this, it came to me that this is working fine, right? Now the only thing which is left is to check if the list already has some nodes, and we will have to find the correct position to insert, right? And what will be that correct position? The correct position is going to be in front of the head. Like this was the queue, like information is coming in this direction, right, and going out this direction. So this is the head. If you're inserting at the front, you will just insert a node over here, and that is pretty simple for someone who knows linked list. But if you don't, I've got your back and I'm showing you how you can do that, right? So you will create a node temp equal to new node with a new value which has just passed in. You will assign this temp.next equal to head, so that for this queue the temp points to the all the nodes one by one, right? And the only thing which is left is changing the head pointer from the current head to the new temp head, right? And that's why we are going to do head is equal to temp, right? But that could have been sufficient, right? But in the future you will see we also need a previous node, right? So to be honest, this line won't be needed right now because we have not understood why previous node would be needed. So when you are doing this code, you would have just left this out, right? You would have just left this out, but because we later on understand that previous will be needed, you will add this up and this will complete the code, and at the same time you will do a size plus plus. Okay, great. But there is even more truth in what I just said. Okay, when I said when we will be coding, at this point we won't be writing head.previous equal to temp, right? Because right now we don't know the value of previous, but that's not really true. If you are someone who is serious about coding, you wouldn't have started coding right away. You have first written down the pseudocode. You would have written down a mathematical structure which ensures that all the functions are working correctly, right? And before writing any piece of code, you would have got all of that fixed, right? So you would have already known before coding that head.previous equal to temp was needed. Okay, so for now let's assume that you had done that and you understand the previous is needed. And if previous is needed in the linked list in the queue, how do we ensure that nothing gets broken, right? So till now you knew that temp.next equal to head will be needed. So because of this, if you have this head and starting queue like this, and you got the temp point to the head, you also want this head to point towards the temp also, right? That's why head.previous would be equal to temp, right? And head is equal to temp. If you don't point this head towards the temp, sometime later the code might break somewhere, right? And there can be so many places it can break if you don't follow this strategy of closing down the small loops, right? And that's why proving mathematically is very, very important. Great. Then we do a size plus plus and then we return true. Great. So our insert front has been done. Similarly, insert last is also going to have the same thing. So what's the difference between inserting front and inserting last? So information is coming in this direction and going out from this direction. So this is a front, this is a rear. So inserting last means a normal NQ operation of a normal queue, so that the new information gets placed over here. So this code you will see is going to be very much similar to that of a circular queue. Okay, so this code is going to be very much similar to that of a circular queue. Of the NQ, so you can see head is equal to, so basically you are assigning the value on the tail, right? You are basically assigning the value on the tail. Even here you will see that we are assigning the value on the tail. Okay, over here the value is being assigned the tail. But of course, if the list or queue is empty, head and tail are the same, so we will have to initialize both of them, right? So if head is equal to null, you will check head is equal to new node, right? You will assign tail equal to head also. You will set size is equal to 1 and you will return true. That's it. Great. And once you have ensured that there is at least one node, that is head is not equal to null, you can insert it at the right position, which is basically behind the tail. And for that you will have to create a new node, temp is equal to new value, right? Then you will set tail.next is equal to temp, right? And then you will set temp.previous also equal to tail, right? For example, let's say this, our list front is over here, tail is over here. So a new temp node is created over here. Tail.next is going to be set equal to this new temp variable, and this temp.previous also needs to point over here, right? And why we are doing this? Because right now it may not make sense to have this also point over here. It may make sense just to see over here, but sooner or later this temp node is going to move all around in the queue. Sometime it may go at the head, okay, sometime it may be present in the middle, right? And at that time our code won't be aware that we had to check this previous node also, and at that time this previous node will be missing and our entire code will break, right? And because of this there are going to be so many situations, and if you are just a random programmer who is just trying to figure out things and write the code, you're going to do a lot of hit and trial. This question is very easy, but when a real question in an interview is asked, you're going to mess things up, and it will become very much obvious to the interviewer when they apply a magnifying glass to your code and they question you and they see that you don't have a proper reasoning why your code works, and it will become a problem, right? So that's why follow proper strategy, right? Master your basics, spend a lot of time on learning that, because that's the difference between someone who will take years and years without getting results and someone who can just do that in 1 month or maximum up till 3 months, right? So for example, my students have done that. They just took training for only 1 month's period, and after that they went from package of 4 lakhs to 21 plus lakh in Microsoft, right? Just in 1 month's training. And how? Because the foundation secret formula they had mastered, right? They had mastered those foundations, and after that all of the pieces of code become cakewalk. Obviously they were not very easy, they had to work very hard, but until and unless you have the direction of your car going in the right direction, no matter what speed you go for, you will always you will never reach your goal, you will go somewhere else, right? So direction is very important, and that direction comes from mastering those foundation and having proper guidance. Okay, so now we are assigning tail.next equal to previous also, right? So both these are maintained, right? And tail is equal to temp, right? Because this was a tail, this was a new node. Now this one becomes the tail, right? Because this was inserted, and size is also increase, and then you will return true. So you are done. Great. Now we come to the deletion part. Deletion also has two kinds of functions over here. One is delete front and the another one is delete last. Delete front basically means a normal DeQue operation, okay, removing from the front. And delete last basically means removing from a position where the node just came in. Okay, so let's see the code of delete front, right? If the head is already null, you cannot delete anything, so it will be false, right? If head.next is equal to null, right? So I have broken down this code into multiple if and else statement, right? If you had been doing the simpler problems that we did before this, right, you would have seen I would have explained to you why there's an if, what are the different conditions, right? It was possible over there to expand on this logic and explain to you. But as we jump onto real data structures, let's say about creating data structures, if I begin to explain those simple principles, the video will explode, right? So again, the same thing. When you have a small problem, don't ignore that and call it silly or simple, but give it a lot of time and try to go as deep as possible in that, right? So that's why here I won't be explaining all the if and else logic, but to a certain extent I will just explain from the surface how things are going, right? Otherwise there's a very proper logic why I chose only these conditions, right? Why I check if head.next is equal to null over here, but I didn't check that in the previous functions. Okay, so we have the head, right, which is not null, so at least one node is there, right? Now you want to delete from front. If you're deleting from the front, there won't be any place. If you simply delete it from the, let's say if the head next was null, what you could have simply done is delete that node and forget about it and set head equal to null. But if that is not the case, if there are multiple nodes, the kind of operation that you're going to perform are going to be different, right? Like for example, as you will see now, okay, so if head.next is equal to null, you will size set the size is equal to 0 because all the nodes will be deleted. You can simply write tail is equal to null, head is equal to null, and you are done. But let's say if there is this condition is false, so there will be at least 2 nodes in this, right? And when there are at least 2 nodes, the only, let's say this is the head, this is the head dot next. So earlier when there was only head, you just forget about it and said head equal to null, tail equal to null. When you have 2, not only will you set head is equal to head dot next, right? You will have to delete this previous pointer also. You will have to delete this previous pointer also, because otherwise this previous will always there, and this is going to cause a lot of mishaps in later part of the code, right? That's why it was important to ensure that you consider the case when there is at least 2 nodes and when there is exactly 1 nodes differently. Of course there's a lot of proofs in this. There's a lot of thinking on how do you cover all the scenarios without leaving any scenario behind that, but superficially on the surface this is what it is, right? That's why you will consider the 2 cases separately, and you will assign head dot next dot previous is equal to null and head is equal to head dot next. You will set size minus minus and you will return true. Okay, great. So delete front has also been done, right? Great. Now comes the interesting question, okay, which is delete last. And it's mainly because of this delete last that you needed the previous pointer. Okay, so let's say you have a node, you have a queue like this starting from here, right? Information is coming from here, so this is the front, this is the end, right? So if you had to delete the last, right, if you have to delete the last one over here, which is actually going to be this one, right? Because information is coming over here, so you're deleting from over here. You will need the previous pointer to get to the, okay, so let's say you have a normal linked list, right? It's going from head to tail, right? If you had to delete the tail node, you need the previous pointer, so that its next can be set to null. But if you are only given the last node, you cannot really delete it, and that's the reason why you need the previous pointer over here. Okay, so because of that, question becomes very much simple. So if head is equal to null, you simply return false. If the head dot next is equal to null, which basically means there's only one, so delete last basically means removing the head itself. So this part of the code is going to be very much same as like this one, right? So we will do this. And if there are at least 2 nodes, what you will do is you will say tail dot previous dot next, right? So this is tail, this is previous, and this is previous, and its next is this. So basically we are assigning null over here. If we had only this node, then we could not access this node. That's why we need the previous pointer. Okay, right now it may seem very intuitive and very easy, but you will need to do a lot of practice, right? And you will have to understand how we have to do a lot of practice of the basic stuff to be able to come up with intuitive things like this, and to be able to break your intuition into real logic, right? Because intuition is not what going to take you ahead. It's the ability of coming up with intuitive solutions and breaking them with the help of logic, analyzing which is the right way and going that ahead, and that to all in your mind, right? And also be able to communicate that to the interviewer if the interviewer asks, right? So intuitively right now it feels good. You may be feeling a bit happy also about yourself. It's good because you are maturing, you are moving a step ahead, right? So don't feel disheartened, keep continuing the practice, keep going ahead, and if possible work on the basics, probably join in the courses also, but don't just give up. Keep doing, keep probably copying the videos, copy the code, and you will be able to understand things well, right? So that's why we are setting tail.previous.next is equal to null, right? And then we set tail is equal to tail.previous, right? So this one was tail, this one was tail, right? So tail is equal to tail.previous. So as a result, this will completely be removed because this pointer has also been removed, and this tail which points to the tail has also become this, and then we will do size minus minus and we will return true, and we will be done. Great. And then these operations are pretty much easy. Get front, you simply return the head value. Get rear, you simply return the tail value. Is empty, you check whether the head is empty, right? Because that's a condition which will always be true. If head is equal to null, you can be sure that size is empty. Another way could be checking size is double equal to 0, because we are maintaining the size, right? And why are we maintaining the size, though there's no need? But the question can ask, is it full? And the only way of finding it is with the help of checking if size is equal to max size, right? Though this is a theoretical limit only in the question, because we are not using an array, a fixed size data structure. We are using simple nodes to do so, so we don't have any limit, right? And that's why it is always suggested to work your way really deep down to small basics, always on the basics. So when, at least when you're practicing, write all your code in terms of basic stuff, so that you can understand how things are working, right? Another way could have been to simply use an array over here, or even a very smart ass thing to do over here would have been that you probably use a queue already in this, right? You could have just used a DeQue which you already implemented and used, directly created an element of that and done that, right? But that doesn't really help, right? Similarly, directly using an array also doesn't really help, doesn't help you think. So work on your problems in this way, at least when you are practicing. When you will be working in an actual interview, my suggestions towards you will completely change, and I will tell you what are the fastest ways to do so. But for now, follow these strategies, right? Master these up. I will realize when you will be interacting with me in the group, I will realize that you have gone through, you have leveled up, right? And then I will suggest you what to do. So do this video, this question properly. Comment below what are the greatest insights you got from this. Maybe those insights might be spoken by me, or maybe it triggered inside you a thinking pattern, made you think about some other problem and come up with solutions to that, right? Or maybe it came to you a new trick which you can apply in different solutions, right? And so do comment below, so that it will help you ingrain also in yourself. When you are commenting publicly, you are sure about what you are saying, and it gives you an urge of emotions and makes you remember things, right? So definitely do that. Be very specific about what you like, and I hope you made proper notes also in this. If you can put your notes also below, that will be really great, because it is going to be helpful for others, and others can comment on that and ask you questions. Further, if you are going to do that, others will feel encouraged to do that. So your notes are going to multiply. Your notes and other person's notes are going to multiply. And remember, there's a lot of abundance in the world, right? What is around you is only a small well. So if you can help all the people around you work hard, learn things, you are going to blossom in the entire world, right? So to give away that need for competition, focus upon cooperation. When you will go into that interview, at that time you can focus on giving your best, right? But right now, help everyone, because you need that exponential level of growth, right? So I hope you enjoyed the video. Click on the link to join the group. Click on the like button also if you like the video, right? Comment below what you loved. Share this video among your friends, and don't forget to subscribe. We will catch you in the next one. Bye bye, take care.